Hello everyone, today let us learn how to model and assemble screw jack parts in Solidworks and generate the following views of the assembly. Front view, right of injection, top view, side view. And the load bearing cup top face is raised to a height of 350 mm in the bearing surface. So this is the cup and this is the bearing surface. That height should be of 350 mm. First let us go through this part list. As you can see here, there are total 7 parts. The first part is the body. This is the body. Second one is the nut. So the second one is the nut. The third one is the screw spindle. The fourth one is the cup. The fifth one is the washer. The sixth one is the countersunk screw. CSK stands for countersunk. So countersunk screw. The seventh one is the tommy bar. Now as you can see here, total 7 parts are there. So let us take the first part, body. So in this, they have given a right of in section. As you can see here, they have taken the section and you can see the hatching. This hatching represents there is a material present. So I will be drawing this profile and I will be revolving this profile around this axis to get the body. Now let us move on to SolidWorks. Open SolidWorks, click on New, double click on Part, right click on Front Plane, go to Sketch. Now here you can select center line. So go to center line, select the center line and draw a center line. Give the height as 185 mm. The height is 185 mm. Next, draw the profile approximately. So start from the base and later you can enter the top. So the base approximate profile you need to draw initially. Then later you can give the complete constraint. So give the dimension, smart dimension from here to here. The distance is 50 mm. And from here to here, the distance is 70 mm. This height is 20 mm. Now I will draw the top face, that is the beginning. So I will draw 2 lines here of some length. Okay. Now give the dimension, smart dimension from here to here. They have given 50. H7 stands for the fundamental deviation of the hole. So capital H is the fundamental deviation. Normally it is 0. H7 stands for the IT grade, tolerance grade. So you need not worry about that. So let's give this 25. And this is 35. This is 35. Height is 40. This is 40. Okay. Now, if you observe carefully here, they have given diameter as 66, right? So what I will do is, I will draw here of 2 mm line. So we'll go to smart dimension. This dimension is 2 mm. This dimension is 2 mm. Then I will try to connect with this. So this is 50 mm. So you can select these two and you can make it vertical so that this distance will become 50. You can cross check. It will be 50, right? You need not dimension it. So now what I will do is I will connect this point to this. Clear? So after this, go to offset entities, select this line, give offset distance of 10 mm, default is 10. Okay. Switch off this select chain, select only this line, click OK. Now if you can see this line get overlapped, intersected by this, or trim the unwanted line. Here you can extend this line. You can extend this, go to extend entities, extend this line. Similarly, you can trim this portion also. Clear? So as you can see here, once the profile is closed, there is a change in the color. So this indicates that profile is closed and ready to revolve. So there are quite few fillets here which can be done later. So this dimension is 3 mm. This dimension is 3 mm. And there are few fillets, that is R8 should be given. Later it can be given. And similarly, you can give radius of 1 mm or 0.5 mm here also. It can be done later. So now I'll exit the sketch. As soon as you exit the sketch, you can see here, sketch is active here. Select revolve. Revolve. Axis of revolution is this. And the profile will be selected automatically. Make sure thin feature is off. Otherwise, it will add extra thickness. Click OK. Now we can see the model, that is the body is created and we can add the chamfers. So that is, fillet. So go to fillet, R8, type 8, select this edge. Click OK. Similarly, here also you can select don't give a bigger radius. You can see it will show you error if you try to give bigger radius. So let us give 1 mm. Yes, that is sufficient. Next part we move on. Save the part as body, BODY, body. Okay. Control-7. Close this file, go to new, and as usual, go to part. Let me go to the part drawing first. So as you can see in this screw spindle, there is a square thread of 38 and pitch is 7. So the distance between one crest to another crest or trough to trough, so that is 7 mm. So that portion will not be available in cosmetic thread. It has to be done with the help of normal threads. But you can see here this is the conventional way of representing threads in drawing. So what we do is we apply the nearby value, that is we'll get around 36 as a metric thread, M36. So that I'll be applying it here. And I'll be creating one more video which gives you a clear understanding about the realistic threads. Suppose normally if you want to 3D print this component, so that video will help you to 3D print this component. Right now, since we use it for annotation purpose, I will go to cosmetic thread and I will apply the nearby value to 38. So as you can see in this profile, similarly this object is symmetrical about this axis, similar to the first object which we created, body. Here is the axis around which this profile can be created and it can be revolved. Right, so let us move on to SolidWorks. Select the front plane, click on revolve, go to center line, draw the center line. Right, so here it can be of construction line or the profile line, not a problem. You can always convert it. You can select the line, you can switch off this for construction, it becomes a normal regular line. Now let me dimension this overall height. So there we go, 240 mm is the overall height. Next, this distance. So this distance is 11, 13, right? So this profile can be drawn with a rough sketch. Later you can give the full dimension because this is 11 mm, right? So this is 13 mm. This is 13 mm and this distance is 10 mm. Similarly, this distance is 10 mm and the distance from here to this location, the distance there again is 83 mm. Similarly, this diameter, so this diameter is 65, so 65 by 2, so 32.5. Next, no need to panic whenever you get this kind of change in the profile. Try to constrain the dimensions. So this is 19 mm. Now you can see this blue color lines. You can just drag it in. You can see here now. See, this looks regular to what we are drawing. Then comes the angle. The given angle as 45 degree. So you can select this and this. Go to smart dimension. Select this and this. Give 45 degree. Similarly, this has been changed. You can see here, everything is constrained, so fully defined. You can see the black color and at the bottom it says fully defined. Now it is ready to revolve. Exit sketch. Axis of revolution. Select this line. Click OK. Axis of revolution. Click OK. This is your front view. This is your top view. Okay. Of screw spindle. Now I have to create a hole as well as I should create a thread here of M12. Similarly, I should create a thread of square thread of 38 into 7. So 38 into 7. Okay. Let me use cosmetic thread option. So go to insert, annotation, cosmetic thread. Select this circle, that is the edge. As soon as you select, based on the selection of the diameter, it will show you the metric threads which are applicable for the given diameter. So right now M36 is available. I'll select M36. The distance they are given us, so you can just see here 240 minus 83, 157, 157 minus 3, it's 154, right? So I'll say 154 mm and say OK. Cosmetic thread has been applied. Go to options, document properties, detailing, shaded cosmetic threads. Click OK. Right? So there is a small gap here for 3 mm. So next, what we do now here is we try to apply M12 also here. So for that, we have an option called hole wizard. Go to hole wizard. Here, select tabbed hole. Okay, tabbed hole. Now M12 option. Just check for M12. It will be available. M12 selected. The length of this, they are given 30, 35. So give the height as 30. 30 is the thread length. So this is 35. Thread is 30. Okay. So M12, 35, 30. Then go to position, 3D sketch. You can see here, center should be found. Place a cursor on the circumference. You will get the center. Place it exactly in this location. Click OK. Now M12 has been created. Control 1 will give you front view. This is how it is. You can go to section and you can see how it appears. Okay, this is exactly in the front plane. It has taken the section. Okay, you can see half of the component. So this is a shortcut for that section view. Okay, once you are happy with the view, you can always switch it off. Switch off this section view, it will disappear. Clear? Control 1, front view. Now we'll create a hole now. So select the front plane as your sketch plane. Go to circle, draw a circle. To draw the circle, make sure the center and the axis are vertical. So hold Control key and select both. Then you go to Smart Dimension. Dimension this hole diameter as 12. Right? See here it can move still. So I should give the distance, that is from the center to this edge, the distance is 35 mm. Now it is completely constrained. So exit the sketch, select the sketch, go to extrude cut. Extrude cut, just tilt it so that you can see the extrude cut. It should be through both the directions. Click OK. Control 1, Control 7. So this is isometric view. Let me create a small chamfer at the top. So go to chamfer, select this edge, give 1 and OK. Okay. Create a small chamfer so that when you insert the countersunk screw, it will not damage the edges. Okay. Now save this part. Control S, screw spindle, screw spindle. Control 7, Control S. Let me close this file and let me create the new file. Close this, go to new part. Let us create the second component now, that is nut. So I'll select the same sketch. You can know that it should be revolved. So select the front plane, go to revolve. Now go to line, draw the profile now. Don't worry about that hole. You will create it. Okay. To get the circle, move the cursor on this point again. You can see here the arc will be created. This is one more way of drawing the line or arc. Okay. Right now, I am not creating any hole here. I'm just creating the component solid. Go to Smart Dimension. They are given this as 15, so the radius will be 25. Then this dimension they are given 10 mm. And this dimension they are given 10 mm. And from here, hold Shift key and click on this circumference. The given distance as 90, so it will be 45. Okay, still the height is not complete, so the overall height is 45. So from here to here, the distance is 45. Okay, now this line can move in and out. So what I will do is I will make it in line. So these two should be collinear. Now you can see it is completely constrained. I'll exit the sketch. Now revolution, it will ask axis of revolution. Select this as axis of revolution. Click OK. So when you do that, component is ready, but without a hole or without a square thread of 38 into 7. So since I have selected M36 for screw spindle, I should select the same thing for this also. So what I'll do, I'll go to hole wizard. I'll select the same option, but here I'll select M36. M36. So through all, position, 3D sketch, place a cursor on this circumference, you'll get the center. Click here, click OK. To see the threads, you can always go to document properties detailing, shade cosmetic threads, click OK. Now you can see the M36 thread which has been applied. Control S. Save this. The third part is nut. Save this part. Still 4 more parts has to be created. So if you want, you can give a small radius here. Go to fillet, radius of 5. Select this, give 5, click OK. So here also you can give around 0.5 mm or 1 mm. Small fillet. Okay. Click OK. Control yes. Save this part. Control 7. Now let us go to the next part, that is the cup. Let me close this. Go to new part. Right, same thing again. So you know you should use revolve. So select the front plane, click on revolve. Here, go to center line. Go to center line. Draw a center line here. Give the height as 42. Total height as 42. Now draw the approximate profile. That is, draw this cup-shaped object. You can see here. Right, approximately. Now keep giving the dimensions. So this and this, this and this should be the same horizontal line. It cannot move above or below. Same thing applies to this also. Hold Control key and select the points. Okay. Now it will not move above or below. After this, they have given the dimensions. Okay. That is the distance between these two, 12 mm. Distance between these two is 12 mm, and distance between these two. Right now it is angle, so let me make this as parallel first. Select this line, make it parallel. Now when you give the dimension, distance between these two will show up. So it is 6 mm. This is 6 mm. Next comes the distance from here to here. The distance is 38, so that means 19. Similarly, from here to here, they are given in the top view 65. So 65 by 2, that is 32.5. Similarly, from here to here, the distance is 22.5 by 2. Okay, 11.25. Now let us revolve this object. Exit sketch. See, automatically it has taken this as the axis of revolution. In the profile, click OK. So the profile is created. Control 7. Give you the symmetric view. 1, 5. Okay. Now let us go to the front view. Select front plane as a sketch plane. Now draw a circle here, exactly in the middle. So you can see the axis origin here. So draw it. Make the smart dimension. This dimension is 10 mm. They are given radius 5. So diameter will be 10. Exit sketch. Now you go to extrude cut and extrude cut both the directions. Through all, both the directions, click OK. The same thing can be done with respect to the right plane. That is, go to right plane, draw a circle, extrude cut. Or if you want, you can always go for creating a circular pattern. Direction. Click on the direction. This is the direction. Right? Which feature you want. This is the feature I want. How many I want. 360 degree. Equispacing. Okay. Equispacing 360 degree. If you click OK, it will create. So this is how you can create the cup. Control 1, Control 5. This is how it appears from top. Control 7. Right, when it comes to the sketch, there is one extra dimension which is given. So either if you try to dimension this point from here to here, it will show 44.5, but in the sketch they have given 45. Either you should change this 11.25 or you need to change this to 22.5. So that 0.5 difference is there, so that can be considered. So I have not considered that 45. I have considered the remaining dimensions, which will make this profile fully defined. That is important. So since the dimensions which I have taken is enough to make this profile fully defined, so I have not considered that 45 mm as the diameter of from here to here. So let me save this file, exit sketch, Control-7, Control-S, cup. I've saved the file. Let me go to the next file, new part. Let me create the washer now. So as usual, select the front plane, revolve, go to center line, or you can directly draw a rectangle here and you can give the dimension. So the diameter is 35, so 17.5. 17.5. Okay. Then this is 8 mm. And now I'll say exit sketch. I'll revolve with respect to this, click OK. Okay, I've created a solid. You can draw the remaining profile as a hole and you can create it. Or else you can go to hole wizard, select ISO, type CSK. Here, very important is this parameters. So you can see in this question, they are given 14.5 is this distance, similarly 25, 90 degree. You can give through all, not a problem. 3D position, 3D sketch, you can place it anywhere on this, right? So place it, select this point, select this axis. You can see y-axis, so along y-axis, you need to place, click OK. So once you do this, this will be created. As you can see here, the washer is created and you can give a small fillet around this edge. Okay. So I'll go to fillet and I'll give around 1 mm this edge, click OK. Control-S, washer, special. Okay, so this is how a washer is created. Control-S, Control-7, Control-5-1, right? Washer is created. Now let us create the next component. Close this file, go to new part, right? Same thing, that is select front plane, revolve, go to line, draw the approximate profile of the component. Okay. Now let us dimension this. So they are given M6, so this will be 6 M12. This will be 6 mm. Overall height from here to here, it will be 30 mm. And they are given this distance from here to here as 24, so it will be 12 mm. Similarly, the distance from here to here is 6 mm. 6 mm. You can see it's fully constrained. You can check the dimension angle, 45 degree will be there. So you need not worry about that angle, right? So now I'll say exit sketch. Axis of revolution is this. Click OK. Done. Next, what I will do is I will try to create a slot exactly in the middle. Control-1. Go to front plane, right? Extrude cut. Now we will use midpoint line to draw a line here, normal line here, here, here. Make sure this midpoint and this axis should be vertical. It should not move anywhere. Now try to dimension this. So this distance they have given clearly, that is 2 mm in the top view, and this distance is 3 mm. Right? Now this should be equal to this. This completes the portion. So exit sketch. Now through all both the directions, as you can see, through all both the directions, click OK. Click OK. So this creates the slot. Now we will apply M12. So once again, as usual, go to insert, cosmetic annotation, cosmetic thread, select this just tilt it, select only this edge. Now you can see M12. They are given the distance. So the overall length is 30. So you can select through all, or you can leave a gap of around 8 mm. So 8 mm is 22 mm. So you can see blind 22 mm. You can say click OK. Once again, to see this, go to Options, Document Properties, Detailing, Shaded Cosmetic Threads, click OK. Now you can see the CSK. So I have taken approximate distance here as 2 mm, and this is total distance is 6, so 8 total distance. So the thread length will be around 22 mm. So you can select through also, not a problem. It can go up to this point. Control 7, Control S. You can go to save this file first. Yes, CSK screw. Here, let me do some small chamfer around this edge as well as this edge. Okay, chamfer around 1 mm. Click OK. Control 1, Control 7, Control S. Save the file. Now let us go to the next component. Close this file. Go to New, Part. Last one is Tommy bar. So select front plane, revolve. Saying go to line, draw a line here, draw a line here, draw a line, draw a line. Complete this. You need to draw an arc here. Let me do it at the later end of the portion. So let me first complete this length. This length is 62. This length is 62. Okay. The diameter they are given as 12, so this will be 6 mm. Will be 6 mm, and the angle will be 135. That is 45 degree. Next, this is 10 mm. So the distance from here to here is 10 mm. Clear? Now comes the overall length. So from this line to this line, the distance is 275. 275. Then the is completely constrained. Let me put an arc here. Okay. Let me draw this arc. We go to arc, select this point, select it, draw an arc. Okay. So you can give the radius, approximate radius, that is, you can give R15. Okay. Next, go to line, extend this, trim this portion of the arc, trim this portion of this line. Okay. So that only this profile is active. Now you can go to Smart Dimension, check from here to here, 275, correct, right? So this arc, let it be blue color, everything is correct. So let me exit sketch, select this, click OK. Control 1, Control isometric. So this is the Tommy bar. At the end, you can apply a small chamfer. So go to chamfer, apply 1 mm chamfer around this edge, click OK. Let me save this file, Tommy bar. So this completes the part modeling. Now let us move on to the assembly. Close this, go to New, Assembly. First part is body, open. Click on the screen, body is fixed. Now let us go to the second component, that is the nut, insert component. So here we have nut, click OK, open. Now apply the mates. So select this, go to mate. Select this cylindrical, click OK. Now drag this up, select this face, click OK. So still this object can rotate. That is why you can see minus symbol here, which indicates that it can rotate, not an issue. Control 1, Control 7. So nut is done. Now let me go to screw spindle, insert it. Now mate, select this, click OK. Don't mate this to this. Why? Because they have given the distance as 350 mm. We need to take into account. So that's why. So whereas it can rotate. So if you observe here, this can rotate. So this rotation motion can be given constraint. Why? Because when you go to the drafting, when you draft it, at that time the Tommy bar should be exactly towards right side and it should be perpendicular to the right profile plane. So in order to do that, we need to make this hole perpendicular to the right profile plane. So in order to do that, what I will do is I'll switch on this temporary axis and I'll select this and select the right plane. Go to mate. So default it will say parallel. I want to make it perpendicular. Click OK. Right? It cannot rotate now. It can move up and down. Why this is important? Because when you go to the top view, when you do the half section at that time, if it is inclined, then section view will not be proper. So only for drafting purpose, we need to constrain this. Practically speaking, this will not be constrained because it has to be rotated. Control 7. Now this has been constrained, can move up and down. Now let me assemble the next component. So 3 components are over. Let me insert the 4th component. So 4th component I insert as cup. As usual, what we should do, we should select this, mate. Okay, click OK. Similarly, I will push this up, select the surface, click OK. Now I have to constrain this also. It can rotate. Okay, how do I constrain this? Is select this, select this, apply parallel. Now it cannot rotate. It cannot move up and down. So it will move along with the spindle, not individually. Click OK. So this is done with screw spindle. Next is the washer. I'll go to insert component. I'll go to washer, open, place it. So similar to all of that. So you can switch off this temporary axis. Go to mate. So select cylindrical surfaces. Right? So many times it will happen. The component will go in and will not be able to see where the component is. At that time, you can always hide the component. Okay? And you'll be able to see the components. For example, now you can see the washer. Now you can always show the components. Right? So in assembly, you can make use of the show components or transparency and you can see where the component is. Right? So this is, let me apply the face mate. Select the screw spindle top surface. Select this bottom surface. Mate. Sorry, I didn't select the mate. Select the mate and apply. Okay. Click OK. So visualize this properly. You can go to wireframe model and you can check. Right. So screw spindle will move above this because you can see the distance. There are 13 mm and 12 mm. 12 mm is in the cup and 13 mm in the screw spindle. So it should sit on top of the screw spindle and properly align. Okay. Wireframe, make it a solid model, Control 7. Now I should insert the CSK screw. So go to insert component, CSK screw, countersunk screw, place it. Now mate this with this, click OK, pull this up. Surface is very important. This surface with respect to this surface. Select this surface, click OK. Right? Now this is not aligned properly because it can rotate. So what I will do is I will select this face and right plane. Select this face and select the right plane. Make it parallel or perpendicular. Right now it has applied parallel. Click OK. Control 1, Control 5. You can see exactly. It can be horizontal also, it can be vertical also. If you want to make it horizontal, you should make it perpendicular. You can go to mates here. You can see the mates which have been applied just recently. You can go to this mates also and you can see it has applied parallel. Right, so you can always go to this mates and you can edit this mate. Edit feature, make it perpendicular. See, it will rotate and it will make it horizontal. Both of them are correct. So it can be horizontal also, it can be vertical also. Control 7, Control 1. Now in the question they are given the top surface of the bearing that is the cup, and the bearing surface should be at a distance of 350. That we will do it now. So go to mate, select this top surface of the cup and select this bottom bearing surface. It will move down, don't worry. Let me click on this distance. So as soon as you click on the distance, you can see now it is maintaining a distance. So the distance they are given in the problem is 350 mm. So by giving this distance, I can fix the spindle distance. Now even once I click OK, it cannot move up or down. It is completely constrained. Clear? Now let me insert the last component, that is Tommy bar. Go to insert component, Tommy bar, click OK, insert it here. Go to mate, the cylindrical surface, click OK. You can select this, you can select this edge. Okay, click OK. Control sign. Right. So let me save this assembly. Control S. So this is ready for drafting. Control S. Go to File, make drawing from assembly. Select A4, switch off, swap the dimensions 297 to 10. Click OK. Right click on sheet 1, properties, first angle projection, apply changes. Go to view palette. Now you can see the various views. Drag it, drop it onto the sheet. So the size is quite small. So let me increase the size. So let me go to custom scale 1:4. Okay, size okay, sufficient. Now go to drawing. Since they have asked for right half in section, go to section view, half section, select right side up, place exactly in the middle. Very important, don't place it anywhere. So it should be in the middle. Now you'll get right half in section. So this is the right half in section of the screw jack. Next, I'll go to projected view, click on the front view to project the side view. This is a side view. Similarly, I can make use of the front view to project the isometric view as well. Right, so this is a side view, this is isometric view. Let me convert this into shaded. Select only the isometric. Go to display style, change it to shaded with edges. Select this isometric view once again. Go to annotation, auto balloon. Click on auto balloon, so you can see the naming. So you can drag this, you can place it here. Okay, auto balloon. So you can drag it according to the space availability. You can place it. Right. So next comes the bill of materials. Once again, select the isometric view. Go to table, bill of materials. Click OK. Place it. Now delete this. Delete column. So retain the part numbers as well as the description of the part. You can edit this. Instead of part number, you can say description. And this is the item number or part number. You can keep it as it is, item number. Okay, quantity. This is about the bill of materials. Next, coming back to the thread portion as well as the knurling part. Dimension, some important dimensioning. So you can dimension some of the important things. This is 140 mm. You know how to remove double zeros. Go to options, document properties. Here we have dimensions, trailing zeros, remove, click OK. Right? So this will remove 140.00. So then they have said top surface of the bearing surface is 350 mm. Correct. Next, they said, okay, this small things you can leave it, or if you can dimension it. From here to here, 185 mm. Nearly from here to here, 70 mm. So dimension some important things of the component. Okay, you cannot dimension everything because it becomes too crowded. Let us discuss about the thread part now. You are not able to see the thread part, so now I should tell you how to add the thread. Select the side view, go to model items, click on this cosmetic thread. This is where the cosmetic thread is. Click OK. Click on yes. So you can see the cosmetic threads. Switch on the hidden lines. Now you'll be able to see everything clearly. Only for side view do it, not for all the views, because you can see there are too many lines here. Now you can see the cosmetic thread which I have applied, which is of M36, but we have to represent, since it is annotation purpose, we have to represent this as square thread of 38x7. So I'll be creating one more video on which a realistic threads, that is actual 38x7, actual knurling will be shown in the video, but that is used for 3D printing. This is used for annotation purpose. So if you give it to any shop floor person, he'll be able to read it and he'll be able to manufacture this. Right. Next, what I will do is I will go to annotation node. I will point towards this and I will name it as square thread. How to add square symbol is go to symbol. Here you will be able to see the square symbol. Square 38x7. Square 38x7. This indicates that this is a square thread of 38x7. Right. Similarly, the knurling part, very important, knurling. So here if you observe that knurling aspect, so I'll go to line and I'll create the box and I can apply knurling. Clear? So go to line and draw a line which covers the entire surface. Now what you should do is you should go to annotation, area hatch fill, hatch this region, only this portion. Okay. For example, I'll show you again. Select the lines which you have drawn. Now you go to area hatch fill. Now you can apply the fill. So you can fill 90 degree. You can see it will appear. Click OK. Right. So this is how knurling has to be applied. Similarly here, I should show the knurling. But for that, I need to dimension this as 100 mm. Dimension this as 100 mm. Complete this with the profile. That is, you need to draw lines here on top of it. Complete this. Now you go to annotation, area hatch fill. You can see fill is ready, done. Similarly, area hatch fill, select the same thing, but the angle is quite different, 90 degree, click OK. So this is how knurling is applied. Now you can show through the annotation that a diamond knurl of 1.6 has been applied. So we are trying to annotate that and knurling has been applied at this region. Right? So this completes the problem. If you have any questions, any doubts related to this, you can ask me. So this line represents this. Okay? You can put it in comment section. Thanks for watching the video.